Hi, today I wanted to talk about another one of your homework problems. It is the top grade turf lawn seed mixture problem. So problem number 2. As you can see here, top grade lawn seed mixture contains 3 types of seed: bluegrass, rye, and Bermuda. The cost per pound, continuing on. Alright, let's take a look at how we do this problem. This is going to be a 3-dimensional problem, much like the problem we covered last time. And in this case, we can either use Wolfram Alpha again, if we so choose, or we can reason our way through this. Alright, so I'm going to assign variables to things. Alright, so top grade lawn and mower seed mixture contains 3 types of seed: bluegrass, the amount of bluegrass I will call X; rye, the amount of rye I'll call Y; and Bermuda, which I will call Z. So X is the pounds of bluegrass seed, Y rye, and Z Bermuda. Alright, so on to the next line. The cost per pound for each of the 3 types of seeds is 23, 14, and 12. Now your numbers will be different. Alright. But more likely than not, you will still have the numbers in descending order. 23, then down to 14, then down to 12. And I've seen a few other people's problems. They are always descending. And that'll be important later. So we look at the cost. The total cost, since we have the money here, the cost is going to equal 23x plus 14y plus 12x. Alright. So cost. So if we had no other constraints, we want to minimize cost here. If we had no other constraints, we just wouldn't produce anything, and it wouldn't cost anything. But we have to produce at least 6,000 pounds. We have that down here. So what we want is, we prefer 6,000 pounds of X rather than 3,000 pounds of Y, rather than 3,000 pounds or 6,000 pounds of X. So each of the batches must contain 25% bluegrass seed. So X is less than or equal to 25T, where T is the total. And the amount of bluegrass must be no more than 2/3 that of rye. Z is less than or equal to 2/3 Y. That is how you read that sentence. Bermuda must be no more than, so if it's no more than that, it could be that, or it could be anything less than that, but it can't be more than that. So Z is less than or equal to 2/3 Y. To fill the current orders, the company must make at least 6,000 pounds of mixture. X plus Y plus Z greater than or equal to 6,000. And that is the total amount that we're talking about, the T I talked about before. How much of each kind of seed should be used to minimize cost? Alright. So we've gone through it, we got the equations. Let's look at the total first. The more that's made, the higher the costs. So even though it's stated it is at least 6,000, to minimize cost we can say that it is equal to 6,000. So X plus Y plus Z is equal to 6,000. So the total amount we produce is 6,000. Now, we go up to our equation here, X less than or equal to 25T. That should be on one line. There we go. X is less than or equal to 25T, where T is the total, so that's X is less than or equal to 0.25 of 6,000. And that gives us X is less than or equal to 1,500. Now, X is the most expensive of the seeds. So we want to have as little of that as possible. So if X is less than or equal to 1,500, X equals 1,500. It's the most expensive. We want to minimize it. So X equals 1,500. A lot of people got this far. Now let's take a look where we need to go from here. We can rewrite our equation. So we have X plus Y plus Z is 6,000. But now we know X is 1,500. So what we can do is say 1,500 plus Y plus Z is equal to 6,000. And this gives us Y plus Z is equal to 4,500. Alright, we have Z is less than or equal to 2/3 Y. So Z is cheaper. Alright, so we want to have as much of Z as possible. So it's less than or equal to, we want the biggest amount, so that's going to be Z is equal to 2/3 y, which if we plug z equals 2/3 y into this equation, we get y plus 2/3 y equals 4,500, or 5/3 y equals 4,500, which gives us y equals 2,700. So we know x, we know y, and we know what x plus y plus z equals, or just y plus z equals 4,500. So I'll put y as 2,700. 2,700 plus z is 4,500, and that gives us z equals 1,800. So we have 1,500 pounds of x, that's here, 2,700 pounds of y, that is here, and 1,800 pounds of z, and that is here. To find the cost, which is $9.39, you simply have to put everything into this equation. 0.23, because they want it in dollars, so we have it in cents up here. 0.23 times 1,500 plus 14, 0.14 times 2,700, finally plus 0.12 times 1,800. Add those all together and you'll get $939, and that will be your minimum. So like I said, two different ways that we can do this. One of them is reasoning it out, and you saw that's what I did over here. Or you get your equations that are here. This is the equation you're trying to minimize, and then you have these constraints. This is less than that. X is less than the total, which is 6,000. You could have to put that in there. All right. And x plus y plus z is equal to 6,000. Or greater than or equal to 6,000 if you want. You put that in Wolfram Alpha, you should get the same answer. But this is a different way to do it. All right. Thank you.